Good afternoon, Doctor. So we are from Group 4, and this is our title: Effect of Reactor Temperature and Feeding Ration on Fed Batch Compositing of Household Food Waste and Green Waste. Alright, so this is our group members. Consists of me, myself, Gabriel Luisiri Anak Stephen, and Agnes Avila Anak Chico, and Shirley Anak Joan. And this is our overall poster. And after this, each of us will explain in detail regarding our criteria in the poster.
Study explore the feasibility of fed batch composting technology for treating household food waste, HFW, and green waste GW in China. Due to the limitation of centralized waste treatment and food waste disposal (FWDS), aerobic composting is identified as the most suitable on-site solution. The study emphasized the importance of optimizing reactor temperature and feeding ratio.
In this study, we used two main composting materials. Household food waste was collected daily from 10 households in Kunshan City, China. All non-organic components like bones and napkins were removed. Then, the food waste was crushed and refrigerated for consistency. Green waste was obtained from a local ecology company. To process this material, we used a fed batch composting reactor. Our experiments were divided into two parts. Experiment 1: investigate the effect of temperature on composting. We tested 4 temperature settings. The feeding ratio of green waste to food waste was fixed at 3:1. Each reactor ran for 60 days with 0.5 kg of food waste added daily. Experiment 2: examine the effect of feeding ratio. We used 4 different ratios. In this case, the reactor temperature was fixed at 50 degrees Celsius, which was identified as optimal temperature in Experiment 1. Again, the composting period was 60 days, with different daily food waste amounts depending on the ratio. To evaluate composting performance, we measure several key parameters. Moisture content, CN ratio, and organics were measured every 3 days. Wave loss was tracked every 2 days. Nutrient level, including nitrogen, phosphorus, and potassium, and the germination index were analyzed at the end of composting. Samples were taken from the top, middle, and bottom layers of each compost pile to ensure uniformity. Each sample was split into 2 parts, one part for drying and chemical analysis, and the other for immediate moisture and seed testing. We also applied a first-order kinetic model to simulate the decomposition of organic matter. The model helped us understand how quickly organic materials degrade over time. This was essential for comparing the effectiveness of different composting conditions. All tests were performed in TryPiclet to ensure accuracy. Data visualization and regression analysis were conducted using Origin Pro, Excel, and SPSS software.
So this is the result. The figure 1A illustrates the moisture fluctuation of composting under different reactor temperature. Moisture is a critical factor in the composting process as it enhances productivity and minimizes negative environmental impact. Figure 1B, the result indicates that the weight loss of the compost increased with the reactor temperature. As shown in Figure 2A, the CN ratio of 4 treatment exhibited a decreasing trend. The CN ratio of the initial substrate mixture of the 4 treatment was 74.0, which did not satisfy the standard of optimal initial CN ratio 20:30. As shown in Figure 2B, the OM content of the 4 treatment continued to decline, but the reduction rate of OM was very different. Figure 3A shows the nutrient content TN, TP, and TK of the compost after composting. The greatest level of TN is 2.9%, TP 1.46%, and TK 1.45% were detected in treatment T4. This demonstrates that high temperature enable better nutrient. Figure 3B of 4 treatment were ranked. Obviously, the GI index of the compost product increased with the reactant temperature.
Figure 4 shows changes in moisture on composting time. Base moisture balance was achieved with feeding ratio 2:1. Too much food waste reduced aeration, causing water evaporation difficulty. For Figure 5, it shows change in C/N ratio on composting time. Faster C/N decreased with higher feeding ratios, which is more food waste. F1 was much slower, reaching maturity only by day 39. For Figure 6, it shows changes in nutrients A and GI B on composting at the feeding ratios. For Figure 7, it shows the observed and simulated first-order kinetics of composting in reactor temperatures.
To conclude our presentation, our study clearly demonstrates that fed batch composting is an effective method for managing household food waste and green waste at a small scale. By carefully adjusting reactor temperature and feeding ratio, we were able to significantly influence the composting performance and the quality of the final compost product. A reactor temperature of 50 degrees Celsius results in the highest composting efficiency, with optimal moisture content, organic matter reduction, nutrient retention, and seed germination index. A feeding ratio of 2 to 1 green waste to food waste was found to be the most effective in promoting organic matter degradation. To
That's all from us, subgroup 4. Thank you, Doctor.